Alright, this is where things get tricky. When you are dividing by a complex number, it's not just the real part, it's not just the imaginary guy right here. You've got to be very, very careful. And this is where you're going to have to multiply times the conjugate. It's a lot like rationalizing denominators from an earlier section in this chapter, where you've got to multiply times the conjugate. So let's do that. So the conjugate of 2 plus 3i, or I guess I should say the complex conjugate, is 2 minus 3i. So we're going to multiply both the numerator and the denominator times 2 minus 3i. Now here's the reason for multiplying times the complex conjugate. As we saw in the other video, when you multiply these guys, things of the form a plus bi times a minus bi will give you the sum of squares, a squared plus b squared. So that's going to make sure that your denominator doesn't have any imaginary stuff in it. So let's go ahead and take care of that. In the numerator, you're just going to distribute, so you're going to have 14 minus 21i. In the denominator, that may be something you just want to kind of scratch out on the side. When I multiply these two guys together, I'm supposed to have the sum of squares. I know that. I'm setting it up this way. When I put the 2 minus 3i, I knew that I was going to be multiplying times the complex conjugate. So when you square this guy, you're going to have 2 squared plus 3 squared. So it's the sum of squares, and then you just do the math. 4 plus 9, and you get 13. So just kind of scratch it out on the side. There's no need to keep writing everything over and over. So all of this is going to be divided by 13. When you are working with complex numbers, remember your end result needs to be a complex number. You need to have things written in the standard form, so the real part, then the imaginary part. And in order for us to finish that here, we just separate this. So that's 14 thirteenths minus, and then we're just going to do 21 over 13, so that's 21 over 13, and we're going to put the I out here to the side. Typical form for writing this is to have the I next to the fraction instead of being in the numerator. It would be the same thing, but we're just kind of going with, I guess, the way it's always done, the way it's always written. Now you would try to look at these guys and see if you could simplify them, but you can't. So you just get out your magic pen to box this, which says, hey, you're done, and hopefully you are right. Of course, hopefully you guys wouldn't mess that up, right? Okay. Let's try this next example. 10 over 5 minus I. 10 over 5 minus I. Again, we're dividing by a complex number, so we need to multiply times the conjugate so that I can make sure that I have only a real number in my denominator. So the conjugate for 5 minus I is 5 plus I. Remember, for the conjugate, the real part stays the same, but it's the imaginary part that changes the sign. Okay, now we're just going to kind of finish this problem like the last one. In the numerator, you have 10 times 5, so you're going to distribute. That's 50 plus 10i. Again, we're just taking this numerator and we're going to distribute. That's all. Now for your denominator, you know it's going to be the sum of squares, so that's 5 squared plus your imaginary part is 1. It's the coefficient of I, so you're just going to write 1 squared, and you're going to finish this. See, if you accidentally write I squared, then you're going to screw the whole thing up, and you won't have the right answer. So the coefficient is 1, so that's why it's going to be 1 squared. And just like the last problem, it's the sum of squares, so just finish this guy. That's going to be 25 plus 1, so that means your denominator is going to be 26. So all of this is divided by 26. And just like we did in the last problem, we want to separate this into the two smaller fractions. So that's 50 over 26 plus 10 over 26i. And you know me, you know this isn't good enough because it's not, dare I say, perfect, but it's not simplified all the way. So, reduce these fractions. So 50 over 26, these guys have a common factor of 2. So we have 25/13 plus the other guy you will also reduce by 2, and that's 5/13 I. So now you can clearly see your real part is 25/13 and your imaginary part is 5/13. Alright. Please make sure that you are buckled in for the next part. This next one is going to be a little bit messier, but we have to go here. You cannot avoid this. I'm going to take 5 minus 2i and divide that by 1 plus 4i. Now the only difference between this problem and the last two problems that we've done is that your numerator is a complex number and it's got 2 terms to it, unlike the other ones that only had 1 term. So, just like the last ones, we need to multiply times the conjugate. And what is the conjugate? 1 minus 4i. Okay. Now, I think you guys know what you're going to have to do in the denominator because it's just going to be the sum of squares. We've been over this. So the sum of squares is going to be 1 squared plus 4 squared. So 1 plus 16 equals 17. So you know your denominator is just going to be 17. Now the numerator is where things get kind of ugly, but fortunately for us, we already know how to multiply this. All you're going to do is FOIL, so let's take care of that. The product of your first terms is just going to be 5. Remember, FOIL. So first terms, and then your outside terms. So your outside terms will give you a minus 20i. And then you go for your inside terms. So that's negative 2i times 1, so minus 2i. And then your last terms. Negative 2i times negative 4i is a positive 8i squared. Don't forget the square here. Now, since we do have I squared, and we said that we should never have anything I squared or higher in your answer, we need to reduce this guy. So a plus 8i squared will become negative 8. So when we combine like terms, we have positive 5 and negative 8, so that's going to be negative 3 from our real part, in the numerator anyway, and then my imaginary part is just going to be a minus 22i. You got your negative 20i, your negative 2i, and all of this is going to be divided by 17. Of course, we want to kind of rewrite this so we have the real part and the imaginary part clearly seen to us. So that's going to be a negative 3/17 minus 22/17 I. So there you go. This one was a little bit more difficult because you had a complex number, full out in both the numerator and the denominator. Things got kind of messy because we had a FOIL in the numerator. The denominator was again that special product, the sum of squares, and that gave me 17. So here's 17 in the denominator, the product of those two binomials in the numerator, simplified, and now in standard form.